Freight Efficiency with NACFE's Mike Roth and Friends.
In episode 19, we're joined by Steve Ernest, Vice President of Engineering for Jacobs Vehicle Systems, where we talk about the evolution of Jacobs over the past 60 years, variable valve actuation, cylinder deactivation, a little on electric trucks, and working with universities and other groups to advance technology. And Steve reminds listeners that diesels will be a viable option for many years to come.
Joining me today is Steve Ernest. He's Vice President of Engineering at Jacobs Vehicle Systems. Hello, Steve. Thanks for joining us on this podcast today.
Oh, thanks for having me.
So let's start with just a little bit about your background and experience and leading up to the work you do now at Jacobs.
Okay. Well, I started my career at a little kind of custom electronics house just out of school, and I worked there for about 3 years, and then transferred over to Cummins Electronics. It was a subsidiary of Cummins Engine Company back in the 90s and the 80s, and I worked there about 6 years and worked on a bunch of fuel injection controls and so forth, natural gas controls, all kinds of stuff. Even some military projects, and then basically I moved out here to the East Coast to work for Jacobs Vehicle Systems 24 years ago. So I've been here ever since.
Wow, we might have crossed paths at Cummins Electronics. I was doing some heat exchanger work back a couple decades ago or more there. So tell us about Jacobs in particular. I mean, we all kind of have a sense of what the history of the company is and what you do, but kind of where has it evolved in the last decade, and kind of what value does your products bring to the diesel engines of today? Okay.
Well, we're about to have our 60th anniversary starting next year, because since 1961 we've been making what most people know is the Jake brake and engine retarders and various flavors of that. So we've been doing that, and probably along around in the mid-'80s, they started playing around with variable valve actuation of one sort or another. Actually, our two-stroke brake, a couple of iterations of that started out in the mid-'80s there, and we kind of revived that back in 2010. I guess I went out there to work on electronics for a fully variable valve actuation system, and so I was there doing that and controls work for quite a while, and so we've spent a lot of time. If you think about the engine brake, it's just a basic engine brake. It is a VVA device, so we've been doing that for almost 60 years. But the fully variable was really what kind of drew me out there, and we worked on that. We continue to work on that. We believe we've got a launch here coming up in a couple of years. We basically spent tons of time on the heavy duty engine, because that's where our money's been made for 60 years. And so I guess after a lot of analysis and things like that, a lot of testing, we've probably been on, 25 different engines. We basically determined that it's worth about 2% fuel economy and 5% in certain, regions, so forth. But that really just wasn't enough to pull it onto the engine. So where we're putting that now is on the really super big engines where they just run 24 hours a day and has a gen set or some sort of pump or something like that, and they're just drinking fuel all day long. So 1 or 2% really pays for itself fairly quickly, because their biggest expense there isn't even the engine; it's the fuel that's being drinking. So
yeah,
the biggest expense there is really just the fuel that it's drinking. So we've been then, I guess, as a part of a VVA effort, we've kind of done a million different little variations of it, and that's really where our emissions work has started from. And so we've taken the fully variable effect and kind of made it a two-position kind of thing, very similar to the original Jake brake in actuation. And so you either get this actuation or that actuation. And so we've got flavors of that, from late intake valve closing to early exhaust valve opening. and then fully cylinder deactivation, where we shut off the valves completely on the overhead. And that's really what we've been working on the last probably, I would say, 10 years. Just because you get with just kind of a 2-position actuator, you get about 80% of the benefit of full VVA with, about 20% of the cost. So it's really, I think we feel like it's a big win for the engine companies that throw a little bit more variability into their engine.
So that is kind of an on-off. That's an on-off, but by cylinder.
It depends on the device, but yeah, for cylinder deactivation, for example, we've got individual actuators that it's actually built into the bridge across the valves, and you can either turn that on, and then you get the valve motion of both the valves, and basically the cam translates its motion through the rocker into the bridge, or you kind of add some oil into the system that feeds through the rocker arm into that bridge, and that ends up disconnecting the bridge, so the rocker still moves up forward, and the motion is just effectively absorbed into the bridge, and the valves don't open. So yeah, we can do that. Depending on how you set up your solenoids, you can set that up to do 3 at once if you want to shut off half the engine on a 6-cylinder, or we've got it so we've been doing demonstrations recently with in combination with Tula, where we've got that control on individual cylinders, and it is really fast enough so that it can do cycle by cycle control of the individual cylinders. So you can really make the thing dance there if you have the right software.
It's really interesting how we've gone from mechanical engines to electronic engines, and then now this is sort of a electronic mechanical. I don't know. I'm trying to think about this. Well, first of all, I have a pretty simple mind around engines and power, Steve, so I'm trying to understand it myself, but also to put it in context. And it does seem like a real natural progression from braking, right? So the company in the classic Jake brake was all about using the engine and saving the foundation brakes for safe and better operation. And here it's expanding into just a different form of kind of the same thing.
Right. It's just you've got an engine there that's robust, and it does the job all the time. You can, since 2007, when they started adding in after treatment on heavy duty, the equation kind of changed. Before it was just can we just do fuel economy? Is that going to be better, or can we improve emissions? All those answers were yes, but all of them were like it would do each of those things a little bit. Of course, we thought, man, we add all those things up, it's a great deal, but it didn't quite work out that way. But now that there's after treatment on there, they just tacked on an extra, $5,000 or $6,000 onto the back of that thing. So now we've got a little bank there. Is the way we kind of look at that. So if we can add something to the engine that then you have to add a little expense there, but then if you can reduce the size of your after treatment because you're always keeping it hot. Now you can take, some of that $5,000, make it $4,000, and I'm sure the after treatment guys are going to be thrilled with me saying that. But basically apply that to the engine or some subset of that, then it's kind of a win for everybody. The overall cost hopefully goes down. The packaging's a little easier because now you've got a smaller after treatment system, and then you kind of put this thing on the engine. And once you have it on the engine, I guess what we've seen initially was, hey, let's throw some fuel injection on the thing. It gives you a little more control. And it was just kind of more of a reliability thing. Then it became, wow, look at this fuel economy you can do. Oh, look at this other little change you can make with the software and cruise control. And, just on and on and on. People have added to it for the last 30 years. The same thing is going to happen, we believe, when you throw a little bit of movement on the valves. That the cam, rocker, and valves have been pretty much the same kind of system since the diesel engine was invented, and it's just like the last little bit of variability that hasn't been put in there. So if we can put that in there, you get a little more flexibility, and now you've got at least times 2 the things you can do with that engine if you take all those other variables and turbos and so forth into play.
So are we really talking about cylinder deactivation here? Where, at some points, so let's say we have a standard 6-cylinder inline truck engine, because that's kind of what, NACFE spends most of our time, and I do.
Right.
then you can basically, to keep the after treatment hot, or if you don't need it, we've got trucks that are incredibly aerodynamic, and some of the flat land cruising is consuming half of the horsepower of the engine, right? But yet you still need all of the engine to get over and climb the Rockies. So are we talking about just completely shutting off part of the engine when it is not needed for power, and to keep that heat up for the after treatment? Is that really what we're talking about here?
Yes, exactly. And so, like, your organization's been, pushing fuel economy for all these years, and there's 1,000 ways to do that, and one of those ways is aerodynamics. So now they've low rolling resistance tires and all the rest, and so now it doesn't take a whole lot, comparatively, to push it through the air. And so when you are in that cruise mode, if you're running all 6 cylinders and they're all kind of at a lower load, they actually start, or going downhill, for example, just before you need the Jake brake, you're just pumping air right through the whole after treatment and cooling it off. And that then means you have to, the controls have to do something to kind of run the engine inefficiently to get the temperatures back up so that it's keeping things clean. So this allows you to just shut off, some number of cylinders, and then the remaining number of cylinders, say you're running at 30% load or something, the remaining number of cylinders are each going to have to work harder, which means they're going to run a little hotter, and then the overall amount of air flowing through the engine gets cut by whatever that fraction is that you've shut off. So it's lower flow and hotter flow, so it does keep the masses of all the after treatment a little warmer. And then you get the side benefit of the just fuel economy generally goes up in those when you're not firing all those cylinders.
Yeah, you get the basic friction, and it becomes a smaller. So how a geeky kind of question for you. I mean, do you shut off the same cylinder every time, or do you go through an algorithm, or how does all that work? Where like hours of you got engine hours, right? But in this scenario, do you try to keep the same amount of hours per cylinder, or is it not that simple?
Well, first of all, I'd love to geek out with you all day long about it, but so we're kind of in that exploratory phase where we're looking at that, and initially we just thought, we'll just make it real simple and cheap, and we'll only put it on 3 cylinders, and we'll just shut them off with one solenoid. Boom. That's probably the cheapest and most balanced solution you can have. But then those 3 cylinders are going to act a certain way, and they may wear differently than the other 3 cylinders that are firing all the time. One of the things we've learned since running all the time is, you got to keep those cylinders a little warm for good combustion. So you really want to just kind of shut them off for X number of cycles. It kind of depends on ambient temperature and all kinds of other stuff. And then you turn them back on once in a while. One of the things that you have to think about is you want to effectively turn each cylinder into a little spring. So you capture air in there, you basically shut off the valves while there's a little exhaust air in there so that it acts as a spring. That way the piston can come up and push against something and then get pushed down. If there's not some pressure in there, like after a little while the air will kind of blow past the rings a little bit. If there's not pressure in there, then you end up, as the piston goes down, you're going to pull a bit of a vacuum, and that's going to suck some oil up through the rings, going the other direction, and then as soon as you start firing that cylinder, it's going to have a bunch of oil mist and stuff in there. So you really don't want to do that. So as we kind of apply this to different engines, we found that there isn't one rule. It's like, it's not, it's 18 cycles. That's the magic number. It depends on that particular ring pack, what kind of compression ratio they have, and 20 other factors. So each one of them has to be kind of calibrated with a cylinder pressure sensor to see where that optimal point is. So that's kind of some of the fun of exploring through this stuff. Is we're literally, I guess for at least me, I'm learning about base things on the engine that I'm sure the analysis guy know for sure, but for me it's still kind of a little bit of discovery going through of different modes. And I think, like I say, once we throw this stuff in there, other really smart people will kind of find all kinds of new ways to apply it, and we'll be different parameters.
Right. Because some people would say that, well, diesel engines have reached their maturity, right? There's nothing new to invent on them, kind of game over, and they're where they are. And we at NACFE and lots of other people just keep in super truck programs, right? With some of these super truck programs getting to 50, 52, 55% brake thermal efficiency. I mean, some kind of unheard of sort of areas of performance. The opportunities don't end. But while I brought up electric, I mean, the buzz sort of everywhere is electric trucks, electric this, electric that. Here at NACFE, we're even doing a lot of work on the electric piece. I mean, from Jacob's pretty engine dominant. I mean, what are you guys hearing, seeing? I think we're probably on the same page that we'll have diesel engines for some time, but there will be a movement. There'll be a movement to, electric in many cases. I mean, how are you guys viewing it, and what are you seeing from your customer base?
Well, we see a lot of press out there of, I think nobody wants to be viewed as, we're going to stick with diesel engines for the long haul and we're doubling down. And we all see that electric vehicles are getting better in capability, batteries are getting better, et cetera, et cetera. But ultimately those batteries are, using electricity that's generated somewhere if it's a plug-in. And there's just applications that, just aren't going to be able to, at least in the current state of the technology, aren't going to be able to just be a switch over to electrics. I'm sure there's, school buses, those are being, put out these days, and that's a perfect application where you're out, you run 40 miles, you drive around, start, stop all day long, and then you go back and charge for 5 hours, go back and pick all the kids up, and then it charges overnight. So that's kind of an out and back, any of those out and back applications, delivery trucks, things like that are medium and light duty certainly will go electric first. And I think that you see, like Volvo was launching one, I saw in the press a couple weeks ago that they had plans to launch this before the end of the year. And of course, my first thought, being a diesel guy, was, does anybody have plans to buy it? And so it just kind of, is it going to be feasible at some point, or is it going to be economical where somebody's going to decide to buy that? And they don't have to buy diesel fuel anymore, but is there some big premium that they're going to have to pay to get this electric vehicle? And people are going to have range anxiety and all these other things. But I'm confident they can overcome that stuff in lots of years of continued research. And the more, there's billions of dollars being put into it now, so people will make breakthroughs and so forth. But we believe that some applications will continue to be diesel. Some of these really long haul things. One of the reasons we're kind of getting into these larger engines, because we feel like those are applications that are going to still remain diesel for a long time. But then kind of as a bridge, I think one of your talks talked about the messy middle between what we have now and what we have for a full electric in the future will be, I think it makes sense, and some of the super trucks we're doing this, to have a hybrid solution. And even the Nikola truck is it's electrically driven, but it's got this fuel cell inside of it, so it's kind of a hybrid. I can certainly see a small diesel engine being that battery charger on some vehicles going forward. And so as we look at our VVA stuff and all of our little things that help out emissions, we can certainly apply those to those engines as well, kind of as part of that messy middle.
Actually, a very good point. So you've got like the classic ICE engine applications, but we've also got hybrids and natural gas. We talk about renewable natural gas and that messy middle and so forth. And there are clearly duty cycles. You think about, I was with a fleet a couple weeks ago that 150 trucks, and all of them are run by team drivers. And so they haul East Coast to West Coast, and then they bring vegetables back. And so, that truck is running 20 hours a day, 21 hours a day. And so
no time to charge.
No time to charge. So the beauty, I mean, I love North American heavy commercial trucks in the trucking industry. it's I curse it because it's so complex, and I love it because it's so complex because there's always a customer for a technology. The question is how many, I guess, when you think about the business of being in the market. But there's so much diversity in it. So in preparing for this, I want to ask you a question about working with universities and research companies, because I know engine manufacturers and then like Jacobs, you guys oftentimes share R&D with universities or technology centers or all of that. I mean, help us understand that a little bit. How is that, and do you end up with really long relationships, like years and decades, to be successful, or can you have shorter projects with different groups?
Well, I suppose some of that is dependent on the scope. We have, since we're out in Connecticut, we have good relationships with University of Connecticut and University of Hartford. There's some other folks around here, and WPI is another one, the Worcester Polytechnic Institute. So we use those kind of local ones. Those are kind of our feeders for engineers that come out of school. So we look to those places for that. And one way to do that is they do these senior design projects. And so you're not going to do some gigantic, PhD level paper with these guys. It's typically one year or one academic year long. So we start working with them in August, and then that'll carry through till the end of the year. And they've got to, we kind of scope it so that it's, the kids can actually do the work. Kind of ideally, it's like an analysis project that then turns into an actual, hey, let's try this with physical parts, make some things, we can do some machining for them, and then kind of prove out of the concept at the end. And what we look for in those projects is, what kind of small problem are we having in either manufacturing or even in our engine lab, a certain test stand. Hey, we've been trying to, test this certain thing, but we just need somebody to apply their energy to it. So we've got a couple of those running this year with UConn. So those are the smaller ones. And then, the ideal world is we kind of create a little brand of Jacobs within that university. And so we've been successful at that with UConn, and people kind of seek us out afterwards. And that includes the Formula SAE guys. And those, a ton of our engineers are former Formula SAE people that worked on those little cars, because we're kind of one of the only automotive places out here.
Well, I think it's just such an interesting thing. We talk about STEM education, and, I've done some work with SAE Baja and some other areas, and it's just always find, I guess, from my own self, always find great value in it, but sometimes also don't do enough of it, meaning, it takes like some kind of spark or some sort of real reason to go create those projects. Once it's done, it's almost always. So I'm wondering how organizations or companies can make it a more intentional part of their business. I'm not saying Jacobs does or doesn't, but how does it become part of our work so we can get those benefits? Right.
Well, I kind of see it as there's a bunch of facets to it. There's okay, this is an HR recruiting thing for some people. That we want to kind of create that pipeline in the future. It's also a way of getting some things done that we need to do it, and it's a bit of advertising. So you kind of have to take a overall view, and everybody's got to, it costs some money to do this. It takes some engineers, time. We've got to go out there and, we kind of judge their senior projects and spend some time doing that. And so you have to kind of decide this thing is worth the investment and overall, because you're not going to say, oh, just doing this one little thing, it'll totally pay off. It's more about, you're building your brand. You're hopefully going to be able to recruit some new engineers, and ultimately just kind of build that goodwill within the local community. I would say we've got since we've been doing CDA and some other technologies, working with Southwest Research and so forth, we've over the years worked with UW-Madison, and we've talked to some of the guys down there at Argonne National Laboratories and Purdue University, and we've got some stuff currently going on with West Virginia University. And sometimes they seek us out, sometimes we seek them out. It kind of depends on kind of who makes the connection. But we've had real good luck with West Virginia the last couple of years. Actually, our intern, not this last summer, but the previous, was one of the guys that was working on some engine work there. So it was great because we worked on a project with him. Then he came up here, worked over the summer on that project. And then when he went back to school, he's actually doing engine testing using some of our hardware. So that's worked out real well for us. And, you mentioned, is it short-term or long-term? I would say that's one of the more long-term ones. And you have to just realize that the pace of academia is not the pace of industry.
Yeah, well, you sure rattled off with Southwest Research and, the different universities. That's sort of the all-star team of, DOE lab. That's kind of the all-star team there. If you're able to have relationships and work with those groups, you're gonna just by nature be successful. So, well, Steve, we're kind of running out of time, but it's so refreshing to talk to somebody that's out there working hard to improve diesel engines. I truly also believe that, we've been improving them for a long time, but there's still some big changes, some big steps, some huge improvements still out there with the newest of technology. So good luck to all what you're doing there. Any final thoughts as we kind of close this out?
As you say, I think we've got a long future in front of us. Just the longevity of any particular diesel engine. When I see California's got legislation that says anything sold after 2035 is going to have to be electric, but somebody's going to sell a diesel engine there in 2034, and that thing's going to be on the road out there for 20 years or more. So we've got a lot of things we can do between now and then to make the diesel engine better, and I think we gotta keep pushing it and keep pushing the envelope there. A lot of investment has moved over to the electric side, but there's still plenty of people like us working on the diesel engine. We're seeing where we can do and kind of make the current stuff better, even as we're working towards the future.
Very good. Hey, I've got to close it there. Thanks for chatting with me, Steve. I really enjoyed it, and good luck to you. We'll look forward to more news from Jacobs down the road.
Sounds good, Mike.
Freight Efficiency with NACV's Mike Rosen Friends.